Hello everyone, in this video we cover the operator precedent parser. So first we see what are the rules when we find out this parser. So first rule is the two operators cannot be adjacent on the right side. Two variables cannot be adjacent on right side. Or the second one is no null on right side of the side production. On right side of the production of production. These two rules for what? For the grammar is operator grammar or not. For checking these two grammar, and for the parser the rules are the different. First we check the grammar is the operator grammar or not. Means if the grammar like this, A read A B C, then these are also two variables. We don't want this in our operator precedent parser. And one more thing is, if A read null, if this is the condition, then this is also not match with our rules. So if the grammar like this, then we change this. So if the condition like this, A read A B C or D, or A B read star, then it is okay, because here no two variables or null is not present. So this is the operator grammar and this is not a operator grammar. So this is the first rule of the parser for the operator precedent. So the first rule is check the grammar is operator grammar or not. So operator grammar is this, means no two variables or no any null is present in the grammar, and this is not a operator grammar. We want operator grammar where two variables or the null is not present. So this is the first rule. Second rule is construct the operator precedent table. Construct operator precedent table. Third one is pass input string, and last generate the parser tree. So let's quickly take the example and understand all the meanings, how the rules are followed in our grammar. So let's start. So let's take the example, the grammar like this: E read EA E RID, A read plus or star. Now first rule is here, check the grammar is operator grammar or not. So if we check this grammar, then two variables are present, these two variables. If we consider these two or these two, so it is not the operator grammar. So we converted this into the operator grammar. So how we convert this? So this A variable is read plus and star. So we replace this A with these terminals. So then our two variables are not coming together. So this E now we change with E, and this A is now we replace with plus, and this E as it is, or because this star is come with or E star E. We replace this A second time with this star, or ID, and A replace with A come as it is star. Now check this is the operator grammar or not. So no two variables are come together, or no any null is present in the grammar. So now it is the operator grammar. So this is our first step. So first step, this is the operator grammar. We convert these two variables into the non operators. So it is the operator grammar. Now second step is construct the operator precedent table. Now how it is drawn? So for this we draw the table like all the non-terminals, and we give them the relation. So for the relation also some rules we must be follow. So first we construct the format of the table. So all the terminals means this ID, plus and the star, these are the terminals. So for the table consider all the terminals. So plus, star and ID. Here also same the sequence follow here vertically, plus, star, ID, and one more symbol we add here, dollar and dollar. As I previously in LL1 also we see in our table we must consider this dollar table, dollar sign. So now this is the format of the parcel table. Now we give the relation. So the relation is always the star. So first we see the rules for the construct the table of the relations. So always star is greater than the divide, is greater than the modulo, is greater than the plus. Now plus has the higher priority than minus, higher priority than ampersand, cap, at the rate and the arrow. And always dollar has a lower priority than all the operators, and ID has a higher priority than all the operators. So remember this flow, and always remember the dollar has the lower priority and ID has the higher priority. And if two symbols are the come same, means star and star is come, then always the left side has the higher priority, or plus and plus, then the left side has the higher priority. So these are the some rules. Remember this sequence, the star has higher priority than divide, then module and plus. The plus has the higher priority than minus, ampersand. These are the sequence of the priorities. So let's construct the table now on the basis of this. So this is the left side and this is the right side. So now plus and plus. So as I mentioned, always the left side has the higher priority. So this is the left side, left and right. So left side has the higher priority. So higher. Plus plus are the equal, that's why this left side plus get higher priority. Then plus and star. So plus and star, from this star has the higher priority. Here mentioned the star has the higher priority than plus. So plus has star has the higher priority, and plus is in the left side and star is at the right side. So we mentioned this. So right side has the higher priority than left side. Then ID. Always ID has the higher priority than all the operators. So always the ID has the higher priority, and ID is present at the right side here. So ID is higher priority, and dollar always has this lower priority, and the operator then higher priority, and this dollar is present at the right side. So this. So plus has the higher priority than dollar. Now plus and star and plus. So star has the higher priority, which is present at the left side. So this star and star, from these two equal sign, the left side has the higher priority. From star and id always get the higher priority, which is present at the right side here. So at the left side, lower priority. And the dollar, always dollar has the lower priority, which is present at the right side. So this, I hope you get the idea. This is nothing but plus and dollar is like this, star and dollar. This is the left side, this is the right side, and always the dollar has lower priority. So directly we write here this. Now id, so id has the higher priority than all the operators. So higher priority, this is also higher priority. And id, from the equal operator, always the left side get the higher priority. So higher priority and higher priority. Now dollar and plus, dollar always has this lower priority. So lower priority, lower priority, lower priority, and dollar get accepted, dollar and dollar get accepted. So this is the table. Now next step is pass the input string. Here we check the grammar. Our grammar is operator grammar. Then we draw the table. Now pass the tree. Next step is, now we consider the input. So it is always mentioned in our exam which string we pass in the input string. So for our example, we pass the string is id plus id star id, and this dollar symbol we always mention at the end of the string. And on the stack always we consider one dollar sign and the action. So this is the, here the relation is present which we mention in our table. This is the action. Now here two action we perform. One is shift and second one is reduce. So this, how it is work, if this string, here this stack is present and here input string is present. So if the string has the higher priority, then we perform the action shift, means push. And if the stack has the higher priority, then input, then we perform pop, which is nothing but the reduce. If stack has input has the higher priority, then we shift the input in the stack, means push the input in the stack. If stack has the higher priority, then we pop the input. Push and pop, I know you know how it is work, means in another word, shift and reduce. So let's we start here. So first the dollar sign as it is, and this is the starting symbol. This is the input id plus star id dollar. Now this dollar and id, what is the relation? See in the table, dollar and id. Dollar has always smaller priority than id because id has the higher priority, so smaller than relation. So smaller than relation. And now as I mentioned here, if the stack has the smaller than the input, means input has the higher priority, then shift the symbol. So here write shift id. Input has the higher priority, so shift this id into the stack. So id dollar, and now this id is shifted, so only plus id star id dollar. Now the id and plus, compare this. So the id in plus, id has always higher priority than any operator, so this relation is higher. If you see here, id and plus, the higher relation is present, so higher. And if the stack has the higher priority, then pop means reduce the symbol, so reduce id. Now id, who generate the id? In our grammar, the id is generated by e, so we want to reduce the id, then write the grammar e produce id, so reduce e produce id. So now shift this id with e dollar, and this plus as it is, id star id dollar. Now again, now this is the non-terminal, we not consider non-terminal, we only consider terminals, which is symbols and the small letters. So this is now symbol in our stack, this dollar and this plus operator, and dollar is always smaller priority, so no need to check the table also, but if you want to confirm them, you check here dollar and plus. So dollar has the smaller priority. Now stack has the smaller priority, then shift, so shift plus, so now we shifted the plus, so plus e dollar. Now here id star id dollar, because plus is shifted. So now stack has the lower priority. If the stack has the lower priority, and sorry, now first we compare, so top of the stack is plus and id always has the higher priority, we are correct, id has the higher priority than any operator. And if we check here, then plus and id, so plus and id the same symbol, id has the higher priority, then write this relation. And if the input has the higher priority, then push the symbol, so here shift id, so id is now shifted here, so id plus e dollar, and this id is shifted, so here star id dollar. Now top of the stack is id, so id and star, id has the higher priority, the symbol is relation is this, then operator, and same here we mention id and star higher priority right here. Now if the stack has the higher priority, then pop the symbol, so we pop the star, we pop the id, not star, we pop the id. And for popping the id, we have grammar is e generated by id, so reduce e produces id. For popping, we pop from the stack, and if stack has the higher priority, then we pop the symbol, so first symbol is id, and this is produces by e, so this id changes now, e plus e dollar. Now next, this star is as it is, id and star. Now this plus and star, so plus has the lower priority than star has the higher priority. And if you check here, then plus and star has the lower priority, and if stack has the lower priority, then pop means reduce, so we perform the action reduce. Now what we reduce? One thing is we reduce with a, because plus is generated by a, plus is generated by a, but instead of this, if we directly pop this whole the things e plus e, because here already e plus e is present. So instead of only consider one symbol, we pop whole the things. So it is for our simplicity easy to understand. So directly we consider this reduction. E produces e plus e. So we reduce this e produces e plus e, and directly we for whole the things we write only e dollar. If you reduce like this plus is changes with a, and EAE if you mention then is also correct, because no impact of the non-terminal create on our symbol stack. But for my simplicity I consider whole the things as e. And now the star, ID and dollar. Now dollar and star, we not consider non-terminals, only terminals. So dollar has always lower priority, and same mention here, dollar and star, lower relation is lower. And now stack has the lower priority. If stack has the lower priority and input has the higher priority, then shift. So we shift the star. So shift star. So now star e dollar, and now star is shifted, so ID dollar. Now we compare this star and ID. So ID has always higher priority, and star and ID if we check here, then this is the relation. Star has the lower priority than ID. Now stack has the lower priority, means we shift action we perform, push this symbol. Now shift the ID. So ID star e dollar, and here now only dollar is present. Now top of the stack is ID dollar. Compare, ID has the higher priority and dollar has the lower priority. Same here, if we see ID and dollar, ID has the highest priority. This is the relation. So same we mention here. So every time no need to check the table from our logic, also we write directly relation, and if the confusion is created then always visit to the table. But now if you perform do the practice again and again, then it is easy to write directly the relation instead of looking always the table, but it need practice more. So now ID means stack has the higher priority than input. Stack has the higher priority, then pop the terminal. So we pop the ID, and ID is produces by E. E is produces ID. So reduce E produces ID. So E star E dollar, and here is also dollar. Now from this star and dollar, so always dollar has the lower priority, and check the table also, star and dollar. Star and dollar, the relation is this, which is mentioned same here. Now if stack has the higher priority, then reduce, and one thing is we reduce only the star which is generated by A, or we directly reduce whole the things E star E, because we get here E star E. So we reduce the whole the term. So reduce E generate E star E. So this is now E dollar, not the relation dollar. Now dollar, because we not consider the non-terminals, we only consider terminals, which are the dollar. Now as in our table we mention, if dollar and dollar is come, then the string is accepted. So same here, the dollar and dollar is come means we accept the string, accept. So our string is accepted by the parser. So this is the way how we pass the input in our parser. Now at the last we draw the tree. Draw tree. For the input, id plus id star id. So how we draw the parser tree? See here. We start from E because our grammar is started with E. So the E. So E read here E plus E star E or ID. So we want first ID plus ID. So if we consider instead of ID we consider E plus E. So this E plus E we put it. Now next, after plus means now if we consider this ID, so E read ID also, so we consider this ID plus ID also come, but we put it later this. So instead of putting randomly anything, we go with our actions. So we go from the bottom. So first here E star E we put, then ID we reduce with the ID, then E plus E and E reduce ID and ID. So same sequence we follow. So first this E read E star E star E, then ID. So we consider this ID later. Now E read E plus E. So as we want, if we reduce this E with again E plus E, and this E now reduce with the ID, then we easily get all the things, because here also 3 times we reduce the ID, and 1 2 3 times ID we consider here also. So first time we consider ID and ID, and as it is what we want, ID plus ID star ID and ID, which we get here, ID plus star ID plus ID star ID. So this is the flow how we solve the parser. So first E star E we consider, then next time we consider ID, so we reduce this ID E with ID, then move forward we replace this ID with E plus E. So E plus E, now reduce this ID with E, reduce this E with ID. So I hope all you get the idea, and if not then let me know in the comment box. Thank you.